It's a basis for calculus. But right triangle trig, which is what we're dealing with, so you can see here a triangle with a right angle, very much a geometry topic. It's kind of where you get introduced to some basic trig ideas. So you'll see intro to trig, and it says we define important trigonometric. All right, so that's what trig is short for. So a little trigonometry, and it has trig ratios. So a lot of trig is just ratios within right triangles. So what we do specifically in this class is right triangle trig. And what you're going to see is one of the ratios that we're going to talk about is the word sine. And then it says the sine, this would be read as the sine of angle A. When we ask that, it's asking you for a ratio. A ratio, like we've been doing, is nothing more than a fraction. So the sine of angle A, whenever we see the word sine, it will always, always, always mean the opposite side over your hypotenuse. So what that means is, let me unhighlight the right angle, because these are all asking about angle A. So highlight angle A, circle it, or whatever. I'm going to highlight it in blue. So this is the reference angle. So we would call this our reference angle. This is where we're standing. This is where we're looking out towards our triangle. If I ask you for the sine of this angle A, so we'll just do it right here. What is the opposite side of angle A? C, A, or B? So if you're standing there looking, which one is the opposite of you, away from you? Gavin, what do you think? A. So if I'm here, the side that's opposite of this is A. Aren't these two adjacent right along it? So we would put that A is the opposite side. Hypotenuse, you better know this one. This one you've known for a number of years now. The hypotenuse is always opposite of the right angle. So if this is your right angle, the opposite side has to be C. And that would be your answer if that was your question. If I asked you for the sine of angle A, it's just A over C. When you see the word cosine, it's a different ratio for a particular angle. So if you see this little abbreviation that just means the cosine of angle A, that means you're going to look at angle A again. And notice how it says adjacent. Notice how a minute ago I just said angle A actually has two adjacent sides, right? Isn't this an adjacent side to angle A and this the adjacent side? When we talk about the word adjacent, it's the non-hypotenuse. So if this is A, isn't this adjacent, but isn't that also your hypotenuse? So that's got to be the C in your denominator because that's the hypotenuse. The other adjacent side, the non-hypotenuse side, is B. So if I ask you what is the cosine of angle A, you're just going to say B over C because that's the adjacent side over your hypotenuse. And then the third one for right now is the word tangent. The tangent is asking you the tangent of some angle is the opposite side over the adjacent side. So see if we understood those first two at all. Look at angle A and put whatever the opposite side is on top, and then put whatever the adjacent side is on the bottom. That's your fraction. That would be your answer. All right, so Jenna, angle A, what did we say was the opposite side of angle A? Yeah, little a, and then what is the adjacent side then? B, because it's the non-hypotenuse side. So yes, there are two adjacent sides to A. Both of these are adjacent, but the adjacent side always means the non-hypotenuse. Okay, so with that in mind now, go to this first little example. Set this, oh, and then off to the side here, sorry, this we don't want to forget. So at some point in your math life, you are going to hear, today is the first time you may have already heard, here's the little trick, the little saying for remembering this, and it's called SOHCAHTOA. All right, does that sound familiar? Has anybody heard that? Okay, you'll hear it a lot, trust me. All right, so here's what SOHCAHTOA means. It's just a little easy phrase, committed to memory. It's an easy thing to remember. But the S stands for sine. So look over here at the sine. Wasn't the sine the opposite side over your hypotenuse? So notice how there's an S, an O, and an H. So the SO means the sine is the opposite over the hypotenuse. When we want the CAH, so ca, C is the first letter in cosine. A is your adjacent, and then your hypotenuse. So the cosine is always the adjacent over the hypotenuse. And then the last one, your tangent, is always the opposite side over the adjacent side. All right. So it's a nice, easy thing to remember. So that when we now go down to letter A, if eventually we don't have all of these written down for you up here, if these weren't here, then we can just remember that, there we go. If we know this, SOHCAHTOA, since I'm asking you for the cosine initially, that means you're looking at this one, because this is the one that starts with the C. The A stands for the adjacent side of angle A. So if this is angle A, again, notice we have two adjacent sides to angle A. But one of them is the hypotenuse, so we want the other one. So the non-hypotenuse adjacent side to angle A is 12. And then the hypotenuse, so this is A is the adjacent, H is the hypotenuse. The hypotenuse is the littles, although we're going to figure this out. Yeah, don't put C down there. Forgot to do one little, you can put C, but we're going to change that. Find what C is for me here. So see if you remember how to do that. Let's actually get that value. Should be a nice value. Okay, what do we get for C? 13. And how'd you do that, Ahmed? Remind everybody.
12 squared plus 9 squared, and then that equals to 144 plus 25, so that's 161. And then I squirreled 169.
What theorem is that?
And then oh yeah, I forgot what the theorem was called.
Anybody remember what this guy's called? Vicky, what's it called?
I forgot.
Oh man, killing me. Christian. Good, the Pythagorean theorem, right? If I have a right triangle and I know two of the three sides, I can do the Pythagorean theorem to figure that out. And then, well, Ahmed didn't know the name of it. He walked us through it. He did 5 squared plus 12 squared equals the C squared. And then he said this is 25. He said this is 144. He added those up. Maybe doesn't look promising when you get those 169 and then you do your square root, but 169 is a nice perfect square of 13.
That's so embarrassing how I just did this wrong. I forgot the name.
That's all right. That's the most important thing. All right, so then from there now, it is your, since it's the cosine is the adjacent side, which we said was the 12, and then the H is your hypotenuse, which we now know to be 13. All right. So when I do sine, we are looking at this one right here. It's the first three letters, SOH. So that's saying that your sine is the opposite side over your hypotenuse. So look at angle B. So now you're looking at angle B. So pay attention to what angle is asking you for the fraction of, the ratio of. So if I am now standing at angle B up here, we want for sine, we want the opposite over the hypotenuse. So SOH. So angle B's opposite side, Gavin, would be what?
Okay.
Which is what number?
12.
Good. So this should be 12. And then the hypotenuse doesn't change regardless of what angle you're standing at. The hypotenuse is still always that 13 that we solved for a second ago. All right, last one, the tangent. This is the TOA. All right, TOA. So what does T stand for? What does O stand for? What does the A stand for? And you're going to write that. And make sure you're doing it with angle B. Confident, Cam? Cam says 12 over 5. Do we agree with that? Good. Because if I'm standing at angle B, which you're supposed to, we want the opposite side, which is the 12. That's the O. And then we want the adjacent side. There are two adjacent sides to B. But the one that's not the hypotenuse would be 5. So that's your adjacent. So 12 over 5. And then that's it. Just writing fractions pretty much. All right, next ones. Do all of those. So I'll give you about 2 minutes. Remember the little phrase. Might sound weird, but SOHCAHTOA. And see if we can come up with those things. Okay, about another 30 seconds and we'll see if we're getting these. All right, let's see where we are at. So we'll do all the A's first. So we'll do sine of A, cosine of A. We'll do all of those first. So when they ask you for the sine, we just understand the idea of SOHCAHTOA here. It's asking for this one. That means we're going to put the opposite side of angle A over the hypotenuse. So if we look at angle A, Megan, what was the opposite side of angle A? Good. And then the hypotenuse for this is always going to be a 10. So that's opposite over hypotenuse. When I go to the cosine of angle A, so here's angle A here, and we are now doing cosine as the adjacent over the hypotenuse. Becca, what do you got? Good. So the adjacent side of angle A, that's not the hypotenuse, is 8. And then the 10 is definitely still your hypotenuse. All right, and then Vicky, the tangent of angle A would, we're here, tangent is the opposite of angle A over the adjacent side of angle A, which is what? Good, 6 over 8. And then that's your answers for those. All right, we go to the other angle. So now we're just looking at angle B. So now we want everything to be that as your reference angle. So the sine of angle B, Jenna, would be what?
8 over 10.
Good. Opposite side of B is 8 over 10. And then the cosine of angle B, so here's B, our cosine Cam would have been what?
6 over 10.
Good, 6 over 10. And then if I go to the tangent of B, opposite side over our adjacent side, Christian, what'd you do for that? Good, 8 over 6. All right. So that's simply sine, cosine, tangent, understanding what those relationships are. And if you just have this down, should kind of take care of itself. All right. Also understand long-term why this would be beneficial, because if I now want to ask what is the degree measure of this angle, don't we have an equation? And isn't B your angle? So eventually what trig allows us to do is figure out what is the degree measure of angle B. Like if I could solve for B, so if I could somehow get rid of this weird sin sine function, then that would actually tell me the degree measure of this angle, right? Which is what we're going to get into soon enough. 3 we're going to skip. And then let me see. Here, this might be actually a good place to stop. Yeah, let's stop here. I kind of want to give a little quiz on this Thursday because I'm not going to be here on Thursday. So this will be kind of a nice thing to kind of go through. We can look at the homework a little bit tomorrow, and then just get a little quiz on this stuff on Thursday. Okay. So if you're home, you guys get an extra 2 minutes. You guys can check out, and then we'll see you tomorrow. Stop this.